In this section, we will study inverse functions. First up, let's do a quick algebra review of inverse functions. The definition of inverse function is that f inverse of x is equal to the set of all points b comma a such that a comma b is an element of f. Now, what that means, for example, say you had a point 1 comma negative 5 that belonged to f of x. Then that means that the point negative 5 comma 1 belongs to f inverse of x. Now notice this notation here, f inverse of x. This negative 1 right here, even though it's in the exponent position, does not mean an exponent of negative 1. This does not mean 1 over f of x. It does not mean that. The way you read this is f inverse of x. Now, the symmetry of inverses, f and f inverse, are symmetric to the line y equals x. And remember that the line y equals x is that 45-degree angled line that goes through quadrants 1 and 3. So if you look at the graph of f of x and the graph of f inverse of x, they will be symmetric to that line, meaning if you folded over your paper on that line, the two graphs would line up with each other. We have a test for inverses. If f of g of x is equal to x, or g of f of x is equal to x, then f and g are inverse functions. Another way of saying that is that g of x is equal to f inverse of x, or f of x is equal to g inverse of x. That's saying the same thing. We can find an inverse function algebraically using these 4 steps. I think the best way to illustrate this is to go through an example and walk through the 4 steps. In this example, we have to find f inverse of x given f of x is equal to the square root of the quantity 8x minus 2. In the first step, we have to find the domain and range of f of x and verify it is 1 to 1. Now, we know that the argument under a radical needs to be greater than or equal to 0. So 8x minus 2 must be greater than or equal to 0, which means 8x has to be greater than or equal to 2, which means x has to be greater than or equal to 2/8, which is the same as 1/4. So then our domain for f of x is 1/4 to positive infinity. We can sketch a graph of f of x. We know the basic shape for the square root curve, and this is going to start at the point 1/4, 0. If we put 1/4 in for x, 8 times a fourth is 2, 2 minus 2 is 0. So we know it's going to start here at 1/4 comma 0 and have the basic square root shape. This is f of x. Now the range, easy to see from the graph. The y values start at 0 and go up. So then that means the range is going to be 0 to positive infinity. And now we can verify that f of x is 1 to 1 because it passes both the vertical and horizontal line tests. So we know f is a 1 to 1 function. Now step 2 is to substitute y for f of x and then switch x and y. So if we substitute y for f of x in the function equation, we would have y equals the square root of 8x minus 2. And then if we go ahead and switch the x and y, we would get that x is equal to the square root of 8y minus 2. Now step 3 says to solve the equation for y. So for this, to solve for y, we would want to square both sides. So now we have x squared is equal to 8y minus 2. Add 2 to both sides. We have x squared plus 2 is equal to 8y. And then divide both sides by 8. We would have 1/8 x squared plus 2 over 8, which we know is 1/4, is equal to y. Now, if we were to look at the graph of y equals 1/8 x squared plus a fourth, we know that it is a parabola whose vertex is 0, 1/4. But now a parabola is definitely not 1 to 1. So we have to be careful to choose the part of this parabola that is actually the inverse function of the graph that we have. Remember that inverse functions switch x and y. So if there's the point 1/4, 0 on the graph of f, then that means there's going to be the point 0, 1/4 on the graph of f inverse. And furthermore, we know that the two graphs will be symmetric to the line y equals x, which means we're going to choose this part of that parabola for f inverse of x. Now notice that we're only picking this part on the positive side, not this part on the negative side. So then that means that f inverse of x is actually going to be 1/8 x squared plus 1/4, provided that x is greater than or equal to 0. Now we have to determine the domain and range of f inverse of x. Now notice when we defined f inverse, we had to put a restriction on the domain so that the graph would be 1 to 1. So we already know that our domain of f inverse is from 0 to positive infinity. And we verify that that's what we see on the graph. It starts at x equals 0 and goes forever in the positive direction. Now the range of f inverse once again we consult the graph. We see the smallest y value on the graph is 1/4, and then the y values only get bigger, so the range is going to be 1/4 to positive infinity. So now I want you to notice something here. The domain of f was 1/4 to positive infinity, and that became the range of f inverse, 1/4 to infinity. whereas the range of f, 0 to infinity, became the domain of f inverse, 0 to infinity. So now we can answer this question: what is the relationship between the domain and range of f of x and f inverse of x? And we notice that the domain of f turns into the range of f inverse, and the range of f turns into the domain of f inverse. And this will happen every time with inverse functions. And the reason it happens, if you think about it, is because by definition, to get from a function to the inverse function, we switch x and y. And we know that x values are associated with domain. So if we switch x and y, it makes sense that the domain of f becomes the range of f inverse, because we just took all the x values and turned them into y values. And likewise, it also makes sense that the range of f becomes the domain of f inverse, because we took all the y values and switched them into x values in the inverse function. In this example, we have to determine whether f of x equals the cube root of the quantity x plus 5 over 2 and g of x equals 2x cubed minus 5 are inverse functions of each other. Remember that the test to determine whether two functions are inverses of each other is if f of g of x is equal to x or g of f of x is equal to x. If we do the composite function f of g of x, then that means we have to take f of 2x cubed minus 5, which would be the cube root of the quantity 2x cubed minus 5 plus 5 over 2. And that would be the cube root of 2x cubed over 2, because this minus 5 and plus 5 would cancel. Then these 2's would cancel, and we have the cube root of x cubed, which we know equals x. And because f of g of x is equal to x, we know that f of x and g of x are inverse functions of each other. Now we could also have checked g of f of x, which means we would do g of the cube root of the quantity x plus 5 over 2, which means we have to take this and plug it into g of x, which would be 2 times the cube root of the quantity x plus 5 over 2 cubed minus 5. Now we know that the cube root of something cubed, those undo each other, so we would have 2 times x plus 5 over 2 minus 5. Now these 2's would cancel, and we have x plus 5 minus 5, which is equal to x. So either way, whether we did f of g of x or g of f of x, we end up with x, which means f of x and g of x are inverse functions. Next, we learn how to prove the existence of an inverse function. To prove that f of x will have an inverse function, you must demonstrate that it is one-to-one. Either of these two methods may be used. First, draw the complete graph of f of x and show that it passes both the vertical line test and the horizontal line test. Second, show that f is monotonic, which means that the sign of f prime of x never changes. Now, of these two methods, the second method is usually faster because drawing the complete graph of f of x, as you know, can take a long time. So let's take a look at an example here where we have to determine whether each function will have an inverse or not. Explain your answer. In part A, we have f of x is equal to x to the fifth plus x to the third minus 7. Using this second method, where we will show that f is monotonic, that means we need to get f prime and analyze its sine graph. So f prime of x is going to equal 5x to the fourth plus 3x squared. We can factor this by taking out an x squared, and we would have left 5x squared plus 3. Now the only critical number we're going to get out of this is x equals 0. So let's take a look at the sine graph for f prime. We know at x equals 0, f prime will equal 0. If we pick a number from this region, say -1, we're going to get a positive times a positive, which is positive. If we pick an x value over here, say 1, then once again we have a positive times a positive. Because f prime never changes sign, we say that f is monotonic increasing. Once we know that f is monotonic increasing, therefore f is one-to-one, and f inverse exists. So this second method of proving the existence of an inverse function goes pretty quickly. Once you have the derivative and look at the sine graph, you can decide if f is monotonic or not. If it is, then it's one-to-one and has an inverse. If it is not, then it's not one-to-one and does not have an inverse. In part B, we have f of x equals x squared plus 2x. F prime of x is going to equal 2x plus 2. We can factor out a 2, and we have x plus 1 left. If we look at the sine graph, our critical number is -1, and f prime is 0 there. If we plug in a test point of -2, the derivative will be negative. And if we plug in a test point of 0, the derivative would be positive. Because the derivative changes sign, that means that f is not monotonic. So we would say, therefore, f is not one-to-one, so no inverse function. Next, we explore the relationships of continuity and differentiability between f of x and f inverse of x. In this example, given the graph of f of x, draw the graph of f inverse of x and make a conclusion about its continuity or differentiability. In part A, we are given this graph of f of x, so the first thing we have to do is draw the graph of f inverse of x. Now remember that from f to f inverse, you switch x and y, and think of folding the graph of f of x over the line y equals x to get f inverse. So if f of x has the point 0, 1, then f inverse is going to have the point 1, 0. And if f of x has the point -2, 5, then f inverse is going to have the point 5, -2. So then the curve would look something like this. And this would be f inverse of x. And what we can see is that if f of x is continuous, which this f of x is, then it makes sense that f inverse of x will also be continuous. Now in part B, we are given this graph of f of x, and so the first order of business will be to draw the graph of f inverse of x. Now I want you to pause the video and try to draw the graph of f inverse on your own, then restart the video when you're ready to check your answer. Now from f to f inverse, we know that we have to switch x and y. So if f of x has the point 3, 0, then that means f inverse will have the point 0, 3. And if f of x has the point 6, 2, then f inverse of x will have the point 2, 6. So then the curve for f inverse will look like this. And we can see that if f of x is increasing, as this graph is, then we look at f inverse of x and see that it's also increasing. In part C, we are given this graph of f of x. So first up, we need to draw f inverse. So pause the video and give that a try on your own. Then restart when you're ready to check your answer. Since the point 1, -2 lives on the graph of f of x, we know the point -2, 1 is going to live on the graph of f inverse. And since 3, -5 lives on f, then that means 5, -3 has to live on the graph of f inverse. Then we have to draw our curve so that if we folded this curve over the line y equals x, it would line up on it. And it's going to look something like this. And we can see that if f of x is decreasing, as this graph is, then it turns out that f inverse of x will also be decreasing. Now in part D, we have this graph of f of x. So pause the video and go ahead and try to draw f inverse, and then restart when you're ready to check. Because 0, 7 lives on the graph of f of x, then we know that 7, 0 is going to live on f inverse. Because -5, 3 is on f, then 3, -5 is going to be on f inverse. And when you get ready to draw the curve, again, imagine that this curve is covered with wet paint and you fold it over this y equals x line, and then that wet paint is going to leave a mark over here in this quadrant. One thing that can help you draw it is you notice that this curve looks like it's approaching y equals 0 as x goes to -infinity, which means this curve would have to approach x equals 0 as y goes to -infinity. A horizontal asymptote on f is going to result in a vertical asymptote on f inverse. Now here we are being asked about what happens if f of x is differentiable at x equals c. So if f of x is differentiable at some point, meaning the derivative exists, then the question is, does that mean f inverse will be differentiable at the corresponding point? And yes, it would. For example, if we used the point -5, 3, we can see that f is differentiable at -5. So x equals -5. However, notice that doesn't mean that f inverse will be differentiable at x equals -5. That means that f inverse will be differentiable at the corresponding point, which is here, at x equals 3. So f inverse is differentiable at x equals 3. So then the question becomes, how do we generalize that? If f of x is differentiable at x equals c, that's what this is saying, then f inverse is differentiable at x equals, well, let's think about where this is. The corresponding x value from f to f inverse is that we have to go -5 turns into 3. So then the question becomes, who is 3? How do I get there from -5? 3 is equal to f of -5. So in other words, the y value on f becomes the x value on f inverse. So if f is differentiable at c, like in our case, f was differentiable at x equals -5, then f inverse is going to be differentiable at x equals f of c. Because remember that 3 is equal to f of -5. So the corresponding point, if you're at x equals c on the graph of f, then you have to be at x equals f of c on the graph of f inverse. And really, this is just another example of x becomes y and y becomes x. The y value on the graph of f becomes the x value on the graph of f inverse. Next up, we have the derivative of f inverse of x. Now let's take a look at this definition here, which looks a little complicated, but really isn't too bad. This says that f inverse prime of x. So the derivative of f inverse at x is going to be 1 over the derivative of f at f inverse of x. Remember that the point a f inverse of a on f inverse will map to the point f inverse of a, comma a on f. So let's look at this picture. Here's the graph of f inverse of x, and we're going to pick a point a, comma f inverse of a. Now we know if we map that onto the graph of f, we have to switch x and y, so it becomes the point whose x value is f inverse of a and whose y value is a. That's all this first sentence is saying. Then the slope of f inverse evaluated at x equals a, that would be this slope right here. So this would be the slope, which is f inverse prime at a. That slope is the reciprocal 1 over the slope of f evaluated at x equals f inverse of a, which would be this slope right here. Now this slope would be found by doing f prime evaluated at that x value, which is f inverse of a. So the slope of f inverse at x equals a is just going to be the reciprocal of the slope of f at the corresponding x value, which would be f inverse of a. Now it makes sense that these slopes are going to be reciprocals. If I know the slope of this line on the graph of f, and then I have to switch x and y values to get to the graph of f inverse, then it makes sense that the slope of this line is going to be the reciprocal of the slope of this line. The x's and y's changed places from f to f inverse. So if this was a slope of 3, this would be a slope of 1/3. And that's all because x and y switch places as you go from f to f inverse. I think one of the best ways to help you understand this is to work through a concrete example here. In this example, we are given f of x is equal to 2x to the fifth plus x cubed plus 1, and we have to find f inverse prime of negative 2. So think about what this means. We have to find the slope of f inverse at x equals negative 2. Now first, we have to decide if f inverse exists. Because if it doesn't, we would stop right there and say we can't do it. So we learned a technique where we can look at the derivative and decide if f of x is monotonic increasing or monotonic decreasing, and if it is, then we know it's 1 to 1 and f inverse would exist. So f prime of x is equal to 10x to the fourth plus 3x squared. I can factor out an x squared, and we would have left 10x squared plus 3. Now looking at the sine graph, the only critical number we have is 0. And looking at test points, if we pick a negative 1, then f prime is positive. If we pick a positive 1, then f prime is positive. So because f is monotonic increasing in this case, it would also work if it was monotonic decreasing. We know that that means that f inverse exists. Now, let's apply the rule that says f inverse prime of a has to equal 1 over f prime of f inverse of a. So in our case, we are evaluating f inverse prime of negative 2, and so we know that's going to equal 1 over f prime of f inverse of negative 2. Now if we knew f inverse, we could plug in negative 2, find out what that value is, then plug that value into f prime, and then we would have our result, which is the slope of f inverse at negative 2. However, we don't have an easy way of finding f inverse in this problem. Imagine if we took f of x, replaced the f of x with y, and then switched x and y. We would have x equals 2y to the fifth plus y to the third plus 1. There's no easy way to isolate the y variable. We can't factor it. We can't isolate it in any way. So we're going to have to come up with another method for finding this value without knowing what the inverse function actually is. So let's come off on the side and do a little work here. We have to live in two worlds, the world of f of x and the world of f inverse of x. So let's make some notes here. F world and f inverse world. We are trying to find f inverse of negative 2, which means we are inputting negative 2 into f inverse, and it would output a y value, which we don't know what that is right now. Now we can translate that to f world, because that would become the point question mark negative 2. The reason we want to do that is because we do have f of x. So here we are saying we don't know what the x value is, but we do know what the y value is. So what we could do is solve 2x to the fifth plus x cubed plus 1 equal to -2. Because we know the y value, we just don't know the x value. Now, because we can't factor this, even if we pulled this over, we wouldn't be able to factor it. So what we're going to do is solve by inspection. And solving by inspection is just a fancy way of saying we're going to guess and see if we can find the x value using guess and check. So typically you'll try some integer values for x. It's not too hard in this case to see that if we let x equal -1, then we would have -2 minus 1 is -3 plus 1 is -2. So since x equals -1, that means in the world of f of x, we have the point -1, comma, -2, which we can then translate to the world of f inverse, and we know that means we have to have the point -2, comma, -1. And what this means is f inverse of -2 equals -1. So even though we don't know who f inverse is, we were able to use some logic to come up with the value for f inverse of -2. So now we can take this value and plug it into our equation, and we get 1 over f prime of -1. Now f prime we do have, that's right here, so this is going to be 1 over 10 times -1 to the fourth plus 3 times -1 squared, which is equal to 1 over 13. So we just discovered that f inverse prime of -2 is equal to 1 over 13. And I want to make sure that you understand what this is telling us. This value tells us that the slope of f inverse at x equals -2 is 1 over 13. So that means we know the slope of f at x equals -1, which would be the corresponding x value. X equals -2 in f inverse world corresponds with x equals -1 in f world. And we know that the slopes are reciprocals, so that slope is 13. And again, this problem didn't ask us to write out these sentences, but I wanted to make sure you understand how to interpret what this means.